Hi everyone, this is a reflection lecture for a video for lecture 10. I'm also going to follow up on that Lewis structure I mentioned in class last Friday. I didn't get a chance to go through. I said I'd go through it on the video. Okay, so today we were talking about bond polarity, molecular geometry, things like that. This sort of picked up where we left off with our POGL. I'm going to go over the exit quiz and again do a Lewis structure example. I also want to mention, if you guys look on Blackboard, I posted our review session time, which is going to be tomorrow at it's Tuesday at 1:40 to 2:40 in Laney Hall. I believe it's 104. And so, again, check out Blackboard for more details. Again, we're going to just be going over some practice problems, hoping to get you guys some more practice on conversion factors and things like that, and the Lewis structures that I know students tend to struggle on for the first exam. And we'll be having our exam in class on Wednesday, about an hour long. If you guys want to come a few minutes early, I'll try and get them out as soon as possible to give you as much time as I can. Okay, without further ado, I'll bring up the exit quiz here. Okay, so this is the exit quiz we did in class today. There was two questions here. One was asking about the geometrical shape of the central carbon of CH2O. Correct answer was trigonal planar, and I'll show you why that is. Looks like the majority of you got that, about 70%. And the second one was asking which of these is not a polar molecule. This one was a little trickier because you have to understand something about the shape of the molecule and the polarity of differences of the bond. Okay. So let's see here. Okay, so if we look here, right, remember whenever we're trying to understand these geometries, we need to start with a Lewis structure. And this is why, again, I mentioned it was really important that you guys are able to draw Lewis structures. Okay, so we have a carbon, two hydrogens, and an oxygen. Or we like to say oxygen likes to form two bonds. It has two lone pairs. Hydrogen likes to form one bond. We have two of those. And carbon likes to form four bonds. Alright, I said we always usually put your carbon in the middle. And if we want to go through the Book's method, remember we said that oxygen has 6 valence electrons. Each of these have 1 valence electron. And carbon has 4 valence electrons. So altogether we've got 6, 8, 12. Alright, and so I bet you put the carbon in the middle, start attaching the other atoms around him. Draw a single bond to each. Right, and now we've got 2, 4, 6, so that means we have 6 left. So that means we're going to put these, I've done something wrong here. 6. Yeah, let's see. I guess that's fine. No, that's right, that's right. So we put our 6 electrons around here. And then you go, and I said you want to count everybody's octet, and so we say, okay, oxygen has an octet here, hydrogen has its 2 electrons, which it wants, but carbon only has 6, and so in order to correct that, you make a double bond, and so our Lewis structure is going to look like this. Okay, and so the question was, what was the geometry of the central carbon? And so you need to look and see how many, remember we want to look for how many electron clouds or charge clouds or electron containing groups around here, and you see we got 1, 2, 3, and we don't have any lone pairs. So if we have 3 electron containing areas and no lone pairs, that they Vesper says that these try to maximize this angle by setting this at 120 degrees. This is what we call trigonal planar. Okay. Alright, and so as I said, most of you all did pretty well on that, but if any of that was not clear for you, I'd recommend reviewing either the POGL or our notes from the past couple days in chapter 4. Alright, so finally, what's not a polar molecule here? We're going to go through. You need to draw Lewis structures of each of these to be able to figure out what their shape's going to be. This one is going to look a lot like our last one. Sorry, that's kind of ugly. H3. I'm going to try and draw a little nicer here. So this one is going to look like this. And you see I'm not even drawing the carbon-hydrogen bonds because those are nonpolar, right? And so we have, right, so this is nonpolar, right? Nonpolar, but we do have a polar bond here. This is more negative than that, and so what we're going to do is we're going to draw a little charge symbol going from our negative to our positive, or from our positive to our negative, like that. Alright, so this is going to be polar. Alright, so now I'm going to do the next one here. Again, you're going to have to look up the values in the table to see which ones are most electronegative. But HF, hopefully everybody can see in the tables, fluorine is one of the most electronegative atoms, so it's going to be delta minus. Try and be consistent here. And hydrogen is delta plus, and so we again, just like last time, draw a little arrow going from positive to negative. Alright, so this is also polar. I'll do this one last, C last, but this one, we're going to draw this out. CH2, then you have this OH. Alright, and so remember this is a bent molecule, or bent at this oxygen, and if we were to look actually at the electronegativity, this is more electronegative than both the hydrogen and the carbon. And so we're going to draw electron density towards the oxygen, and so this is considered polar. Alright, so finally, process of elimination here. So this is an example. I showed something similar to this called carbon tetrachloride in class. What you have is carbon with 4 bromines on it. And we said that this is, if you look in your table from the book, you'll see that bromine is more electronegative than carbon, so these all have slight negatives on them. Carbon has a slight positive. But if you'll see the way this looks in space, this is a tetrahedral geometry, and so you actually have essentially, your charges moving in all directions, they all counteract each other. Right, so even though this has polar bonds in it, all of these are not polar because they cancel out. This one cancels that one, or that one, this one cancels that one, and so the net non-polar. Alright, so the correct answer for this was that carbon tetrabromine, bromine is the non-polar. Okay, so with that said, I've already drawn a number of Lewis structures, but I was just going to do one more. This is one I said I'd do in class, but didn't have time to do. So the CN here is a cyanide group or a cyano group, and so we have hydrogen, which likes to form one bond, one valence electron. We have carbon, which likes to form 4 bonds, which has 4 valence electrons, and we have nitrogen, which likes to form 3 bonds, which has 3 valence electrons. So total, we have 7, 8 valence electrons. Okay, so we're going to arrange these, like I said, you usually put the carbon in the middle, nitrogen on one side, hydrogen on the other, and we start putting our, right now we use 4 of our valence electrons, and so we're going to put our, we should have 3, we got, oh wait, math, not so good, sorry, we have 5 valence electrons there, apologize, so we have 10 valence electrons altogether, so that means that we spent 2 on bonds, that means we have 6 remaining, put our valence electrons around there. Now we look for our octets. Hydrogen has its octet fulfilled. Nitrogen has 1, 2, 3, 4, 5, 6, 7, 8. But carbon only has 1, 2, 3, 4. So carbon is missing 4 electrons. So what we're going to do is we're going to have nitrogen form 2 double bonds here. And so this is what we call triple bond. So HC 1, 2, 3 bonds. Nitrogen still has 1 lone pair remaining. Now we do our counting. We have nitrogen has 1, 2, 3, 4, 5, 6, 7, 8, and carbon has 1, 2, 3, 4, 5, 6, 7, 8. So everybody's happy. Okay, so that's how you do that. Again, we're going to get some more practice with this tomorrow, and I'll see you in class then.